Data handling. Chapter 5, we are going to introduce a new chapter of Mathematics Class 8th, whose name is Data Handling. So looking for information. In our daily lives, we are always looking or gathering some sort of information based upon certain events. In your day-to-day life, you might have come across information such as runs made by a batsman in the last 10 test matches, number of wickets taken by a bowler in the last 10 one-day internationals, marks scored by the students of your class in the mathematics unit test, or number of story books read by each of your friends, etc. So here we observe that we have different aspects of our life, and the similar thing is that we are gathering some sort of information. The information collected in all such cases is called data. So this is the basic definition of data. Data is usually collected in the context of a situation that we want to study, that we just discussed here. For example, a teacher may like to know the average height of students in her class. And why would she like to know it? There could be a selection going on for the basketball match in the school. For that, they might need certain students of certain heights. So to find this, she will write the heights of all the students in our class, organize the data in a systematic manner, and then interpret it accordingly. After writing all the heights of the students, sometimes data is represented graphically, that we studied in previous standard of 7th, to give a clear idea of what it represents. Do you remember the different types of graphs which we have learned in earlier classes? Well, yes, we represented the data in the terms of pictograph. So pictograph looks like this. For an instance, if we are talking about cars, so we will depict one picture of a car for every 100 cars. It says one symbol stands for 100 cars. For an instance, if a company produced in July 250 cars, so the same shall be represented like this: 100, 100, and this half picture represents 50 cars. It also says this half picture denotes half of 100, which will be equal to 50 cars. Now, in the month of August, we have 3 complete cars drawn. It means 100 plus 100 plus 100 equals to 300 cars. In September, we have to find how many cars were produced by the company. So 1, 2, 3, 4. 4 into 100 equals to 400 cars produced in September. So we can say how many cars were produced in the month of July. It is already provided to us, 250. In which month were maximum number of cars produced? Obviously, here we visually inspect that here more cars are shown. That means we have the maximum number of cars produced in September, and we already discussed it's 400 cars. So the representation that we just studied was the pictorial representation of the data. Second form we studied in previous standard was a bar graph. Therefore, a display of information using bars of uniform width, their heights being proportional to their respective values, is termed as a bar graph. So if you observe here, we are provided a bar graph. Let's inspect it. On x-axis, this is called x-axis, and this is called y-axis. On x-axis, we are provided academic years. That is from 2003 to 4, from 4 to 5. For simplicity, let's just write it as for 2003, 2004, 2005, and so on till 2007. These are the academic years, and based upon that, we are provided number of students of class 8th. That is, in 2003, we had 100 students in class 8th of any particular school, whose name is not provided to us. So it says bar heights give the quantity for each category. That is, for the category 2003, or for the year 2003, in this case, we have 100 students in class 8th. Similarly, for the other years as well, bars are of equal width with equal gap in between. So you see, this width is equal to rest of the widths of the bars. Also, the gap in between these bars will always be equal. So such type of representation is termed as a bar graph. Now based upon this, let's try to answer the questions. It says, what is the information given by the bar graph that we just studied? It is providing us the information about number of students in class 8th in different years from 2003 to 2007. That is our first part. Second one, in which year is the increase in the number of students maximum? Consider these bars as staircases. So the maximum distance between any two staircases or bars in this case will give us increase in the number of students, which is maximum. By visual inspection we see that here the rise is maximum. That is, this step length is maximum than other steps. Therefore we can say for the second part that for the year 2004 there was an increase in the number of students that was maximum, and it was from 100 to 200. There was an increase of 100 students in 2004 as compared to 2003. Then third part, in which year is the number of students maximum? It is just asking for the value. So the maximum students, we see highest height of any bar is for year 2007 and 8. So it is 350. Therefore for third we have in the year 2007 we have maximum students. Now we have to provide whether information provided here is correct or false. It says the number of students during 2005 is twice that of 2003. Well, for 2003 we had 100 students, and for 2005 we have 250. Is 250 twice of 100? No, it is even greater. Twice would be 200. It is 50 more than that. So this is a false statement. Therefore we learn from this representation that there are various information that we can get from a bar graph. Third type of representation we are going to study is double bar graph. Simply there will be two bar graphs attached to each other. So it says a bar graph showing two sets of data simultaneously. It is useful for the comparison of the data. In case of simple bar graph, we were only visualizing or studying about one event only. But in case of double bar graph, we study about two different things at the same time. This we will understand when we will try to understand this particular given double bar graph. So here are the hints. For 2005 and 6 we have colorless bar graph drawn, and for 2006 and 7 we have darker bar graph drawn. So let's study the first question. What is the information given by the double bar graph? Well, we observe on the x-axis we are provided with the 5 different subjects, and it is being compared for the years 2005 and 6 at the same time, and the number of marks obtained by a student. So in this double bar graph we are getting information about a particular student, not a group of students, about a particular student who got certain marks in mathematics, social science, science, English, Hindi in 2 years. So that is the information this double bar graph is providing to us. Second question, in which subject has the performance improved the most? Well, if you see for English, he deteriorated. That is, no improvement is here. He degraded his marks because in 2005 he got 50 marks, whereas in 2006 his marks were lower. It lies somewhere between, that is 45 marks. So clearly this is not the case of our consideration, that is English subject. He degraded in this. But the question is asking in which subject has the performance improved the most. So with this you got the idea where this gap will be maximum between these two subjects. Here it is equal. That is, his marks are equal in both these years for Hindi subject. Well, if you observe for mathematics, here the slope is higher. That is, in 2005 he got 30 marks in maths, whereas in 2006 he got 60 marks. That is, he increased by 30 marks as his performance. So clearly mathematics is the answer for second part. So we observe how clearly we get various information by just representing double bar graph. Now, in which subject has the performance deteriorated? Well, we have just discussed it is English, and we have told the reason why. That is the answer for third part. In which subject is the performance at par? By par we means that his performance is at the top notch. So it is Hindi clearly, because if we add both these marks of 2 years, then we see in Hindi he got 60 in 2005 as well as 60 in 2006. So 120 marks overall in Hindi, therefore this subject performance is at par. We cannot say maths is at par, although he has improved. But when we will add both these marks, it would be 60 plus 30, so 90 marks. But at par means at the highest level. So he has maintained his level in case of Hindi. Therefore, performance at par for subject Hindi in both these years. So that is our fourth part. So that was all about double bar graph, and we get a better comparison in case of double bar graph. Think, discuss and write. If we change the position of any of the bars of the bar graph, would it change the information being conveyed? Why? This means if we will place mathematics after social science, will it affect the overall information? Well, no. If we are shifting both these bar graphs at the same time, then the information inferred from this double bar graph will not change. But if we are only shifting one at a time, that is, we are displacing their positions. For instance, if we are depicting this darker bar graph at this place and this darker one at this place, then indeed the information will change, because that mapping will go wrong. Whereas if we shift entire subject, maths over here or Hindi over here, then information inferred from that will not change, considering we do not change the heights of these bars. Well, that is the answer for this part. Now try these. Well, you can try these, but we can give you a hint that which representation will be best for these type of events. Draw an appropriate graph to represent the following information. So we are provided with the months from July to December and number of watches sold. This representation can be easily done on a simple bar graph, which you can try yourself. Second one, children who prefer walking and cycling from 3 different schools, school A, school B, school C. Well, here we have a comparison. So double bar graph should be used in order to represent this information. Third one, percentage wins in One Day International by 8 top cricket teams. So here are the nations whose cricket teams performed in these 2 events. Again, it is a comparison, so double bar graph should be used in this case. Now, organizing data. It's alright, we have collected the data, but in order to get some meaningful information about it, we need to organize it. Therefore, next step after collecting data is we have to organize it. And you must understand this, the basic difference between data and information is this only. The first step that we collect is not the actual information, it is called the data. And when we process it, it is called the information. That is, when we can get some valuable outcome out of any data, then we call it as an information. We do not call it data later on. So it says usually data available to us is in an unorganized form called raw data. To draw meaningful inference or information, we need to organize the data systematically. For example, a group of students was asked for their favorite subject. The results were as listed below. So these are different favorite subjects of different students. So it says which of the most liked subject and the one least liked. So the number of more times any subject will come in this raw data will be the popular one or the most liked one. The least number of times any subject comes will be least liked. So you see, we need to organize it. That is what we are going to study next. It is not easy to answer the question looking at the choices written haphazardly. We arrange the data in the table 5.1, that is over here, using tally marks, which we have already discussed in previous standard 7th. So for art, we have 5 plus 2, 7 students who like art subject. And for mathematics, we have 5 students, and so on for the rest of the subjects. Now, if we have forgotten how we are drawing these tally marks, well, let's give an example for English. So let's consider English. For each instance, we will draw a pipe sign. We are talking about English. So we encounter English over here, we cut it and we put one tally mark. It is just a pipe sign, perpendicular pipe sign. Then English again, we put another pipe sign. Then we have English again, then again pipe sign. We are cutting it so that we do not read it again. Then we have English. Well, here we are cutting it and putting another one. Well, we do not see any English subject. Therefore, 4 pipelines or 4 tally marks. That's why the 4 has been represented in case of English. Now for mathematics. Here we have mathematics. So 1 tally mark. Again mathematics. Another tally mark. Again mathematics. 3rd tally mark. Mathematics. Tally mark. Now we have last mathematics. The only difference over here is for the 5th instance, we will put a cross sign like this. So the same has been shown over here for mathematics, and for the rest of the subject you may do, because you got the idea now. Now why we cross it? For just a good looking perspective. So when we will write it, we do not have to count it 1, 2, 3, 4, 5. We know when we have crossed it, that means these are 5. The rest of the remaining tally marks we can count. So we can easily write 5 plus 2, 7, 5 because it is crossed. The only important thing is that you must put this cross after 4. Then only you will be sure that the number of students written are correct. Now you got the idea. Let's move further. The number of tallies before each subject gives the number of students who like that particular subject. This is called the frequency, or the number of times particular instance is repeating. It's called as the frequency. So the frequency gives the number of times that particular entry occurs. So we can say from the table 5.1, frequency of students who like English is how much? 4. Frequency of students who like mathematics is how much? 5. So the same has been written over here, 4 and 5. Now the table made is also known as frequency distribution table. So here we have 3 terms. Table, because it is a representation in a tabular form. Distribution, we are distributing different instances in terms of rows, and frequency because we are collecting the number of times particular instance is happening. By instance we mean subjects. It could be anything based upon our area of interest. Now it says we have to try these. So you can do it. It is just a representation of different pets a group of students would like to have. You can construct such representation using tally marks that we have already discussed. Grouping data. The data regarding choice of subjects shows the occurrence of each of the entries several times. That is the frequency. For example, art is liked by 7 students, mathematics by 5. This information can be displayed graphically using a pictograph or a bar graph, because these subjects are less and we are talking about less number of children. Sometimes, however, we have to deal with a larger data. For an instance, if we are talking about a population of a city, here it says, consider the following marks out of 50 obtained in mathematics by 60 students of class 8th. So these are 50 students who got these much of marks in mathematics for class 8th. It could be any class, this is just a noise in the question. Now, if we make a frequency distribution, which we indeed can, table for each observation, then the table would be too long. So for convenience, we make groups of observations, say 0 to 10, how many students fall under this category, from 10 to 20, how many students fall under 10 to 20, and so on. Based upon that, we are performing tally marks, and so on, and obtain a frequency distribution of a number of observations falling in each group. Thus, the frequency distribution table for the above data can be like this, and so on and so forth. You can do it by your own. So when we will add up all these frequencies, that should come equal to 60, because what is this frequency? These are the number of students, and we already know that we are talking about 60 students. So these are the total. Now, data presented in this manner is said to be grouped. So whenever you hear about this word grouped, that means we are considering classes or classification, and the distribution obtained is called grouped frequency distribution. We know very well about frequency distribution from our earlier discussion, but when we are considering groups, that is, we are categorizing in different classes, that means it will be called as group frequency distribution. So nothing fancy, just break all the words and you get the idea about what we are talking. It helps us to draw meaningful inferences like. So number first, most of the students have scored between 20 to 40. How? Well, this is the largest frequency and these number of students fall under 20 to 30. Therefore, we can say that 21 students, which are maximum of 60 students, they got the marks in between 20 to 30. So that is our first. Second, 8 students have scored more than 40 marks out of 50 and so on. It is talking about more than 40 marks. So more than 40 simply means it could be 40 to 60. So we will add both these number of students. 7 plus 1 is 8. Therefore, 8 students have scored more than 40 marks out of 50 and so on. Each of groups 0 to 10, 10 to 20, 20 to 30 is called a class interval. So these classifications is termed as class interval. 0 to 10 is one class interval. Then we have 10 to 20, another class interval. So in total we have 1, 2, 3, 4, 5, 6 class intervals. Or in short, you can only call it as a class. This word came from the classification. Do not get puzzled with the class as you have in your school. It is just a short form of classification. This could go with any area of interest. We will call it class if we are talking about cricket matches. We will again call it class if we are talking about population. So it is not a class that you have in your school. Now here is the problem. Observe that 10 occurs in both the classes, that is from 0 to 10 as well as from 10 to 20. Well, if we observe, if any student will get 10 marks, then in which class we shall put him? It says, but it is not possible that an observation, say 10 or 20, can belong simultaneously to two classes. That is just what we have discussed. To avoid this, we adopt the convention. What is the convention? That is the standard procedure or the standard protocol that we consider globally, that the common observation will belong to the higher class. That is, if the number of students get 10 marks, we will not consider in this class. Rather, we will consider the students who got 10 marks in the next class, that is, in the higher class. Also, for an example, a student gets 40 marks. So we will not consider that student in this class. Rather, we will consider him in this next higher class, that is from 40 to 50. That is what this discussion says. It says 10 belongs to the class interval 10 to 20 and not from 0 to 10. Similarly, 20 belongs to 20 to 30 and not 10 to 20. That is the higher class. In the class interval 10 to 20, 10 is called the lower class limit and 20 is called upper class limit. For an instance, here in this class, 50 will be termed as lower class limit and 60 will be called as higher class limit. So these are just the nomenclature that is globally accepted. Similarly, in the class interval from 20 to 30, 20 is the lower class limit and 30 is the upper class limit. That is what we just discussed. Observe that the difference between the upper class limit and lower class limit for each of the class interval is 10. That is, from 0 to 10, difference is 10. 10 to 20, again difference is 10. 20 to 30, again the difference is 10. So this difference is called width or size of the class interval, and that should remain constant. Else, your representation has no meaningful data. Based upon the discussion, we must try these. Study the following frequency distribution table. Now, with the distribution, you know that we are distributing, that is, classes will come. So this thought should strike in your mind because most of the students get puzzled in this word itself. So frequency means we are going to consider the number of times that particular instance is happening. Frequency distribution of daily income of 550 workers of a factory. Now based upon that, let's try to answer these questions. What is the size of the class interval? Well, this is just the difference, and this difference will be constant in each class interval, or simply the class. So consider this, or you may consider any class for that matter, 250 to 275. There is a difference of 25. Again, if you observe here, 300 and 325. there is a difference of 25. Therefore, we can say the size or the width of the class interval. Second one is which class has the highest frequency. Clearly, when we visualize the frequency, we see 140 that correspond to 200 to 225 has the highest frequency. Third one, which class has the lowest frequency? Well, 20 seems lower. Well, we observe, yes, 20 is the lowest and it corresponds to 300 to 325. So this class has the lowest frequency. Now, which is the upper limit of the class interval 250 to 275? We do not need to look at the table itself. So upper limit will be 275. And similarly, lower limit will be 250. That is our fourth part. Fifth, which two classes have the same frequency? So the number which is same for the two classes, 4525. Do we have 4525? Well, we don't have. 55. Yes, we have 55. So these two classes, 150 and 175, also 225 to 250 have the same frequency as 55. So you see how easily we get meaningful data from the grouped frequency distribution. Second question asks, construct a frequency distribution table for the data of weights in kg of 20 students of class using interval 30 to 35, 35 to 40, and so on. So by this understanding, you can easily construct this question. Bars with a difference. Let us again consider a grouped frequency distribution of the marks obtained by 60 students in mathematics test. So this is the information that has been depicted in this grouped frequency distribution. Again, grouped means we are going to have classes, that is the classification, and frequency means number of times that particular instance is happening. So the thought should strike in your mind when we talk about group, that we are talking about classes. This is displayed graphically as in adjoining figure. The same has been represented over here. Now the question is this graph in any ways different from the bar graphs which you have drawn in class 7th? Well, let's observe it. Well, yes, here all the bars are concatenated. That is, there is no gap in between. So observe that. Here we have represented the groups of observation. Again, here we have groups, not the actual number of students on the x-axis. That is from 0 to 10, 10 to 20, 20 to 30. That is the class intervals are represented on x-axis. This is one of the differences. And then the height of the bars show the frequency of the class interval. So this height simply represents the frequency of the class interval. That is, for an instance, 40 to 50 class interval is over here. So 7 students obtained marks from 40 to 50. So the same has been shown with the height. Also, there is no gap that we just discussed. The graphical representation of data in this manner is called a histogram. So this is the difference between a bar graph with a histogram, that there are no gaps in between, and on x-axis we have class intervals. So such type of representation will be termed as a histogram. So here we are provided with another histogram. Let's study the different representations. So the range is divided in equal 5 intervals, because you see from 20 to 25, 5 is the difference, 25 to 35 is the difference, and so on. So this is the width of these class intervals. New thing over here is this jagged line or broken line. This is like this. It simply means that we are not showing the numbers between 0 to 20. That is, our information is such that we do not have any data from 0 to 20. Data starts from 20 to 25, because we are talking about number of teachers whose age is greater than 20 years in a school, because a teacher cannot have an age less than 20 in this school. Therefore, whenever you observe a broken line, it means we are not starting from 0 class interval. So that is the difference. Rest of the information you know very well, that these bars will be concatenated, that is, there will be no gap, and height of the bar gives the number of data items in a particular group and is the frequency. Now based upon this, let's try to answer these two questions. From the bars of the histogram, we can answer the following questions. How many teachers are of age 45 years or more but less than 50 years? So teachers from 45 to 50. So 45 to 50 we have these number of teachers. This is 5, as your answer. Second part, how many teachers are of age less than 35 years? That is up to 34 years, because we discussed that someone who falls at 35 years will be considered under this height. So less than 35 means up to 34. So these three groups frequency we have to add. So 6 plus 4 is 10, 10 plus 5 is 15. So the answer for this is 15. Now try these. So this is the histogram. Again, this means we are not starting from the 0 interval. We are starting from 125 and the width is 5, because when we subtract all these differences of these class intervals, it is 5. Now, what information is being given in the histogram? The information provided to us is, we are provided with the heights in centimeter of number of girls of class 8th. So there is no girl whose height is 124 centimeter or less. Therefore, this jagged line has been shown. That answers first part. Second part, which group contains maximum girls? Well, maximum is this height. So we have 7 girls whose height fall under 140 to 144. So always keep this thing in mind. That is, the value that falls on the boundary line will be considered on next higher class interval, or simply a class. That is the answer for second part. Third, how many girls have height of 145 centimeter and more? 145 centimeter or more, because 145 will be categorized under this category. So addition of all these three will give us the answer. So 4 plus 2, 6 plus 1, 7 girls. It is asking more, that's why we added up. Now, fourth part. We have divided the girls into following three categories. How many would there be in each group? Group A, 150 centimeter and more. For that, 150 centimeter and more, 2 plus 1 is 3. So for group A, 3 girls. Group B, 140 centimeter to less than 150. So 140 is over here, so we will consider this till 150, less than 150. So it will be this thing, not this one, because 150 will fall over here, but we are asked to find less than 150, that is still 149. So it will be 7 plus 4, 11. So for group B, we have 11. Less than 140 centimeter. Well, less than 140 centimeter, that is up to 139. We will have these 3 bars for addition. So 3 plus 2 is 5, plus 1 is 6. Therefore, 6 students for group C. So we observe, with the help of histogram, we can easily collect information of a large data. So this was the introduction for our chapter named Data Handling for Standard 8th. Based upon that, we shall try to solve exercise 5.1 in next tutorial.